Hello all, hope you well. Today lesson we are going to look at further symmetric properties as well as the Pythagorean identity. So we are going to understand complementary relationship as well as the Pythagorean identity. So let's dive in. I have given you a quarter circle here, that's all we need, and bit more maybe later. In here again we are going to look at where my point P is. Let me get different colors so that you can see. Also I can show my colors, isn't it? Right. The point P is here, which has an angle theta subtended at the center. Now what I'm going to do is I'm going to move this point to another point where the angle between the vertical line and that line OP is theta. Well, if you look at these two triangles, the very first one, let's say OPQ, and this one again, let's say OP dash in this case, P dash and Q dash, these two triangles are congruent. They're exactly the same. They have the same corresponding angles, and these are 90 degrees. Therefore, the length and the heights for each triangle has to be the same. So let's try to connect that one using circular functions. The first one we can consider is the height here. Let me get a different color so that we differentiate nicely. The height for the first triangle is exactly same as, in this case, if you see upside down triangle, that will be your length here. So right, how do I write down the height in terms of theta? We know that it is sine theta. Now for this particular point that I'm going to put here, the length across that way, the horizontal length, is same as that height and can be written using this particular angle. And I know this is 90 degrees. If that is theta, the angle that I'm looking at here is 90 minus theta, which is pi on 2 minus theta. Hence, I can write down that length as cos pi on 2 minus theta. Using the two triangles, the congruency, you know the height here, that length is that length, exactly the same. If you can just think of length of a side of a triangle. Therefore, we can write cos pi on 2 minus theta has to be exactly same as sine theta. Well, we can use this one later to solve problems. Let me see that. That is cos theta using my first triangle and the point P where the angle subtended at the center is theta. And I know that in the same manner I can write down this height using the angle pi on 2 minus theta, because that's pi on 2 minus theta. That will be sine pi on 2 minus theta. The heights are always sine, the lengths are always cosine. Well, the ones written in purple are exactly the same. Hence, I can write down sine pi on 2 minus theta is equal to cos theta. Well, how do we actually just think of this one in more sort of like number sense? Let's say theta is equal to 30 degrees. Okay, what it means for us using the first, let me write that in a different color so that we can write 30 degrees. Now I'm going to use the same colors that I used before. Now what it says for this one, cos. Well, it says 90 minus theta. My theta is 30. 90 minus theta should be 60, isn't it? Simple calculation. Is equal to sine, my theta is 30. So what does this mean? This means if I am on the unit circle, the height at 30 degrees is exactly same as the length at 60 degrees. That's what it is. So if you get a point which has a 30 degree subtended at the center as well as 60, there's another point, the length here is exactly same as the height there. That's what it is. Well, we have two equations here. That is when we find that particular triangle in the first quadrant. How about if I extend that point, or if I move that point to the second quadrant where I'm going to go another theta after 90 degrees. That's our second one. So let's go in here. In this particular diagram, I haven't stopped theta before 90. Rather, I went past 90 degrees and then went another theta, which means 90 plus theta, pi on 2 plus theta. Well, fair enough. Now again, if you look at same manner, the length here is same as the height there. Therefore, I can write down the length for that one is cos pi on 2 plus theta. The angle, cos of the angle is your length, is now same as for this particular triangle. They are congruent. If you look at carefully, is exactly same as that height, which is sine theta. Now, what you need to make sure is it's about the length. Now, if I look at the value sense, it is negative. Therefore, you must put a negative sign in the front. Hence, we get cos pi on 2 plus theta equals to negative sine theta. So let me write down that one a little bit more clearly. Okay, now what we can consider is we can consider this particular height just in here. I know the height, which is exactly same as that height, is written as sine. So sine, what is the angle? Pi on 2 plus theta. Now I know the height here is exactly same as the length here, which is cos theta. And in the second quadrant, my height is positive. Therefore, I don't need to put a negative sign in the front because they're both positive. Hence, we have two equations here. So we are going to use these two equations to solve problems. Let's have a look at a couple of examples before we move into Pythagorean identity. So let's say we've been given if sine theta is equal to 0.6, I want you to find, let's say, cos pi on 2 minus theta, let's say, and cos x, another one, is 0.7 or maybe 0.3, another lucky number. I want you to find that, and cos pi on 2 plus theta. Here, sine pi on 2 minus x, and then here sine pi on 2 plus x. So if you look at earlier equations, we have cos pi on 2 minus sine pi on 2 minus. We have to remember this. So you gotta remember these equations. And I know cos pi on 2 minus theta is sine theta. Therefore 0.6. Hence cos pi on 2 minus theta is equal to 0.6. Cos pi on 2 plus theta is in fact negative sine theta. Therefore negative 0.6. Well, you get the answers quite quickly if you remember the relationship. Sine pi on 2 minus x is, we got as cos x. Well, that is in here 0.3. Again, sine pi on 2 plus x also cos x, which is 0.3. Hence, both of these values are 0.3. Well, now let's look at Pythagorean identity. Again, I'm going to pull the point here where the angle subtended here is theta, and we know the height is sine theta and length is the cosine theta for this particular triangle, OPM. Well, using the Pythagoras theorem, we can write down OP squared is equal to OM squared plus MP squared. So let's say OM squared plus MP squared is equal to OP squared. Well, OM is cosine, cos theta, so cos squared theta, plus this one is sine squared theta because the length is height is sine, or rather length of that side. Then OP is 1, therefore 1 squared is 1. Hence, that's our relationship. Well, how do we use this one in calculations? Let's say that I've been given sine theta is equal to let's say 1 on 3. Okay, I need to find cosine theta, so that's where we need to go down to. So I need the value for my question mark. Now what we're going to do is we're going to apply the Pythagorean identity. Let's say here cos squared theta plus, I know sine squared theta is 1/3 squared is equal to 1. Simple calculation gives me this is 1. What is 1/3 squared? 1 on 9. So you take away 1 on 9. That gives me what? That gives me 8 on 9. Nice one. That's in fact cos squared theta, not cos theta. Well, we get the question mark. Cos theta is now equal to plus or minus square root of 8 on 9. Now ladies and gents, here we have to use simplifying surds, everything. Connect your knowledge. Root 8 is 2 root 2 and root 9 is 3. Well, I have two solutions to cos theta. How do I find the correct one? Obviously, doctor hasn't given you the condition, has he? Right, here I'm going to give you. Now let's say assume theta is acute. What it means is in the first quadrant. What is the understanding for you for cos theta? The length in the first quadrant. Any point on the circumference while you're walking on the circumference, in the first quadrant, the length always positive. Therefore, for the purple condition, cos theta is equal to 2 root 2 on 3. Well, that's the way. Let's say I have another condition to this one, exactly the same way. I'm going to pull a different color. Let's say I'm going to take this color. I haven't shown that color to you. Okay, let's say theta, in this case, obtuse. So for the obtuse angles, you got to be very careful here. In this case, I have chosen sine theta is 1/3. In a second quadrant, in the second quadrant, obtuse angle, which means just in here, if the theta was there, the height is still 1/3 is okay because it is positive. But the length here, you can see it's negative. Therefore, what you need to write down is, since that condition, I'm going to give you the condition, therefore you use the condition. You got to pull this one from the question. You got to read very carefully. And then you write down, for that particular condition, cos theta has to be negative. Therefore, negative 2 root 2 on 3. So what you must remember all is you have to consider which quadrant you are in based on the question. In this example, I haven't started giving you the condition. If I gave you the condition, you would have ended up with one solution. The reason I didn't put was I needed to discuss these two variations. Now, hope you understood that. If you have any further questions, please get back to me. I would be happy to do a screencast and get back to you. On that note, happy learning, and I'll catch you soon in another video lesson. Bye. Thank you.